All right, before you start filling it out, you better listen. Okay, everybody listen up. There's only two classes that not like people classes. There's only two types of classes that I really don't like. That's today's class and tomorrow in teaching long division, right? I don't teach you guys long division, but I do teach that to the 7th graders. I don't like today's class because I have too many, and they're always boys. I'll have too many boys that will hear nothing of what I'm about to say. And then a week from now, you're not listening, especially boys. A week from now, I'll have these boys come up to me and say, I don't know how to do this solving equation stuff. I'm lost. The reason why you're lost is because you didn't pay attention on the first couple of days. The very first comment that I heard someone say is, this is easy, right? Yes, absolutely 100%. There is nothing, in fact, this is what you saw in first grade. This is first grade work that we're about to do. The only difference between first grade is now is they didn't say that you were solving an algebra problem in first grade. Today we're going to say you're solving an algebra problem. In first grade, instead of it having the letter X, they put a box. They said, what plus 2 is 6? And you put 4. You were doing algebra then, you just didn't know it. The difference today is I'm going to teach you how to do algebra. Those of you that had me last year, you have this exact same class. You get it one more time, and then we move on to the more challenging stuff that you didn't have last year. Algebra only gets more challenging when there's more steps added. The paradox is that the steps are always the same. It's always you do one step at a time. So today I'm going to teach you how to solve a one-step equation. It only takes one step. If you are writing right now and you are doing it incorrect, I will give you double homework. Okay? Meaning that if you're just writing an answer and you're not showing me the work, if you're just writing the answer, you're not showing me the work. I'm thinking Christian's probably doing that right now because he did it last year. You have to learn one-step equations to solve a 6-step equation, which you will have this year. It's just 6 one-step equations. You have to learn how to do each step. That learning process starts today. So for those of you that are paying attention, which I'm sure is not everyone, you got to follow these steps. Okay? So yes, we're going to do algebra for this entire chapter. I love the chapter. I do not like the first class, which is today. 1, because it's very rudimentary. And then 2, no matter how many times, I haven't figured this out yet. It's only my 11th year doing it. No matter how many times I do this, I will have, and it's always boys, I will have these boys say, that's stupid. Why are you doing things the hard way? I already know the answer is 4. I'm just going to put 4. I'm going to pay no attention to the teacher. And then a week from now, when we have that 6-step equation, they don't know what to do because you didn't pay attention on day 1. All right. So the calendar, of course, that does that. I haven't graded it yet. It was a test. It wasn't a quiz. All right. So the calendar, we got a long ways to go. This is a very long chapter. It takes 3 weeks to get through it. Why? When we get to the end, I'll show you one of the questions at the end, and it is shockingly challenging. Okay? But trust me when I say if you pay attention, all of algebra is easy. This part of algebra, solving equations. Okay. I will in a second. All right, copy down your homework. You must do the steps tonight for homework. You cannot write the answers. You must show the steps. I will get painfully mean with you if you're not showing me the steps. Yes? Sure. You must show the steps. Jaden. I hate 1 and 2. 1 and 2 try to give you a different. Some kids can't wrap their head around solving equations. So sections 1 and 2 start off with trying to show you why algebra works. I think that you guys will be able to handle it without doing 1 and 2. So I never teach section 1 and 2. Yes, sir. Your planner? Let's hold off for just a second. She was getting her math books. Yeah. All right, we good? I'll let you go at the end of class. Okay. So, solving algebraic equations. First, I'll give you a quick history lesson. Ready? Put your pencil down on the board. Quick history lesson. So, solving algebraic equations. We probably know one of those words, equations. But some of you don't know what the word solve means. Solve does not mean get to the answer. That's simplify. Simplify means do the math. 2 plus 2 is 4. Solve means something else. You may think that what you've been doing is solving. You haven't solved yet except one time last year. You don't solve 2 plus 2. You simplify 2 plus 2. Okay? Algebraic, you also don't understand what that means. So, a quick note. What is algebraic? An algebraic equation is an equation that has at least one variable. It does say equation, so it has to be an equation. Hey, here's an equation, but there's no variable. This is not an algebraic equation, right? That is an algebraic equation. It has a variable x. Be careful. We're not going to use x for multiplication from now on. That means a variable. Now it says at least one. This year we will have equations that have 2 variables. I don't think we ever see one that has 3. I could be wrong, but for sure we'll see one that has 2. Okay, are you paying attention? Some of you aren't. Okay. All right, so both of these are algebraic equations. This is just a plain old equation. So algebra, that's a funny word, right? Geometry means measure the earth. Earth, metric, right? But algebra is a weird word. Anybody know where it comes from? It's not Spanish, right? What? It is not German. What? Turns out that it's Arabic. I don't even know what that is. Which is ironic because I showed you a picture of Persia. For those of you that don't know it, Persians are not Arabs. Arabs are not Persians. Persian is what we would call modern-day Iran. The Persian Empire was one of the longest-lasting empires of all times. Hey, Rome was dead a long time before the Persian Empire. Persian Empire died in 1925, right? Some of you may have grandparents that were alive during the Persian Empire, okay? Persian Empire. I mean, it covered all the way from Greece down to Egypt, all the way to India. This is the largest extent of the Persian Empire, okay? 1925 was much smaller. All right, around 820 AD in Iraq, modern-day Iraq, in the city of Baghdad, there was a dude, right? And his name was Al-Khwarizmi. Al-Khwarizmi is where you need to show your hatred if you do not like algebra, because he's the guy that came up with it, a Persian, right? A Persian came up with this. Now, this is a Russian stamp, but obviously we don't have a photograph of him. But that's a depiction of him. He is one of the most famous mathematicians of all time. He is literally... Quiet. Stop. He is literally the person that came up with this thing called algebra. This is the cover of his book. His book had a very long title. Now, Arabic, this is Arabic writing. Even though he was Persian, Arabic is read from right to left, top to bottom. So we would read it from here across, here across. The title is right here, and the title translated is The Compendious Book on Calculation by Completion and Balancing. Okay, compendious just means a large book that covers everything, and you can understand the rest of those words there. Stop now. In Arabic, right, this is, I can't read Arabic very well, but it says Al-Kitab al-Muqtasar fi Hisab al-Jabr wal-Muqabala, right? That is what I just said in English, which is the Compendious Book on Calculation by Completion and Balancing. And just remember, they read from right to left. So I put it from left to right. Okay. Well, there's 2 words there that match up perfectly, and it's those 2 words. What are those 2 words? Al-Jabr and completion. Al-Jabr is Arabic for completion. And that, Al-Jabr, is where we get the English word. So algebra means completion. Okay. Now, what does it mean to complete something? Well, completion means you take an equation that is algebraic. That means it has at least one variable, and you complete this. Hey, you are not even trying to pay attention. Stop what you're doing and look at the board. You know who I'm talking to. To complete this equation, we must find what x stands for. Anybody can do this in their head real quick?
6.
Okay. Apparently no one in this class. Jace?
3.
X has to equal, x has to equal 3. 3, it's 3. Okay, back up here, please. Now, for those of you that can't figure out the answer is 3, don't worry. That's what I'm going to teach you in this chapter. All of you, by the end of the chapter, this will be a simple one, can be able to solve this algebraically. Okay? So 3 is what would complete this. 2 times 3 is 6, plus 5 is 11. Okay? That's algebra. Okay? A quick note. During this entire process, I will be talking about the left side and the right side. Please pay attention right now. I hate when a week from now I say, look at the left side, and Jenna has no idea what I'm talking about. Jenna, where's the left side of this equation? Where's the left side? Which numbers are on the left side? Just 2? Okay, and 10 is just that? Is this 5 on the left side? Okay, for those of you that need to hear this, and Jenna heard this last year, but she doesn't remember this. The equal sign separates the left side from the right side. When I say look at the right side, where does your eyeball go to? No, where does your eyeball go to in order to figure out where the right side is? You look at the equal sign. That's the middle, even though it may not physically be the middle. Like if this is just 5, you're like, well, that's not the middle, right? Equal sign is the middle of the equation. It separates right side from left side. Okay? We good? Our book will abbreviate right-hand side and left-hand side with LHS and RHS. So if you see that in the book, that's what they mean. Look at the left-hand side. Look at the right-hand side. So that's key point number 1. You guys that had me last year did this 4 times. I'm going to make you this year do it 3 times. So look at box number 1. There are 3 boxes. You're going to do this for 3 straight days. On the 3rd day, if I can have one person tell me all the, you're still going to write it the 3rd day. If you can have one person tell me all this stuff, I will pick you at random. I will pick. You will not copy it down a 4th day. If that one person can't tell me this, we're all writing it down a 4th, and a 5th, and the 6th day until we have it memorized. In algebra, there are 3 key ideas. 3 key ideas. You're going to put 1 in each box in box 1. In algebra, we talk about solving the equation. What does that mean? In algebra, when you ask you to solve the equation, it means get the variable. Write down what's in red. Get the variable by itself, which is a weird thing. If you've never done algebra before, this doesn't make much sense. What do you mean, get the variable by itself? I mean, you're going to do some math. You're going to do multiple steps. Eventually, the variable, in this case, x, will be all by itself on one side, either the left side or the right side, and on the other side will be the answer. Some math teachers, I say it as well, say isolate the variable. The goal in algebra is to isolate the variable. That just means get rid of everything except for the variable x or z or whatever the variable is. So we will do some math. This one will take 3 steps. We will do 3 steps. Eventually, x will be on the left side, and on the right side will be the answer. The solution. I put a question mark there because you guys don't know how to solve this right now. You will. This is kind of a medium one this year. Algebra 1, we don't spend much time on solving equations. Instruction, we do solve equations all the time. But in Algebra 1, you're expected to already know how to solve equations. Key idea number 1. Key idea number 2 is, okay, I got to get rid of things. I got to isolate the variable. I got to get it by itself. That means you got to get rid of numbers. There's numbers attached to x. The rule in algebra, because it's a balanced equation, is whatever you do to one side, you must do to the other side. Do not be the one person in class that I call on and screws this up for the class. Make sure you have this written down and you memorize these three things. We're going to do it for 3 days. On the third day, I'm going to call on someone. Get it right, and the class will reward you. Get it wrong, and the class will have ill feelings towards you. All right, whatever you do to one side, do the other side. Let's investigate that. Okay, here's an equation. I got a left side and I got a right side. It says whatever you do to one side, you do to the other side. Let's just take, for instance, that we add 10 to the left side. If we add 10 to the left side, what do you have to do to the right side? You got to add 10 to both sides. It's like a person lifting weights or a balance, right? If you want to keep it balanced, you have to add or subtract or multiply or divide the same thing to both sides. So if I add 10 to the left side, I also must add 10 to the right side. That's what keeps it balanced. Okay? So, to give you another example, is this a balanced equation right now? Does the left side equal the right side?
Yes.
Okay, so if I add the same thing to both sides, does it remain balanced?
Yes.
Well, we get a different answer. We don't get 10 equals 10, but we get another balanced equation. 12 does equal 12. This works with subtraction. This works with multiplication. It also works with division, but I don't think I gave you an example. Okay. But here's what happens. Get it? Here's what happens if you don't do the same thing to both sides. It starts off with 10 equals 10, but what do we get here? And that's not balanced anymore. You did not add the same thing to both sides. So you must, this is the, I don't know, the number 2 or number 3 thing that a student will screw up. It's not that they don't remember this, they just don't do it. They're like, well, they get so excited, oh, let me add 10 to the right side. They forget to also add 10 to the left side. Don't forget to do the same thing to both sides. So here's the first 2. The last one is this. So we got to get rid of something. How do you get rid of something? Well, in math, we do the inverse. If you want to get rid of a plus 2, you got to subtract 2. If you want to get rid of a multiply by 2, you gotta divide by 2. To get rid of a divide by 2, to get rid of a subtract 2, I think I covered them all. There are more inverses than that, but those are the 4 that you will use. Well, there's a 5th one, but we'll talk about it in a few chapters. Those are the inverses that we will use this year. There are 4 of them. There's a 5th one, but not until later when we get to geometry. The inverse of addition is, the inverse of subtraction is, the inverse of multiplication is, and the inverse of division is. I usually don't have kids write that down because most kids intuitively get that. Genevieve? There is an inverse of exponents. Absolutely 100%. There is. That's the one that I will teach you this year. Okay? But we'll do that when we get to geometry. All right. So if I want to get rid of minus 10, what's the inverse of subtract 10? If I add 10 to both sides, whatever you do to one side, do this side, what's 10 minus 10? Poof, it goes away. It's no longer there. I got rid of 10. Now, granted, the other side changes from 14 to 24, but there's no longer a 10 attached to x. Our goal in algebra is to get the x by itself, to isolate it. This is called a 2-step equation because there's 2 numbers you have to get rid of. We'll do 2 steps the day after tomorrow, and then 3 steps and 4 steps and 5 steps and 6 steps. Okay? We don't get much beyond a 5-step. I'll show you a 6-step, but we don't get much beyond a 5-step this year. And even in Algebra 1, we don't generally do more than 5 or 6 steps. Okay, so here's the 3 key ideas that you must have memorized. Okay, when we talk about actually doing the algebra, just like in most things that I teach, I come up with steps, right? Now, you're not going to see this in a book anywhere, but these are the words when we're solving equations that I will always tell you. Like when we're doing adding, subtracting integers, I say, hey, same or different signs, add or subtract, big minus small, more negatives, more positives. I do the same thing for algebra. and I call them the 3 questions in the 1 statement. So remember, our main goal is to isolate the variable, to get x by itself. Whatever's on the other side is the answer. So here are the steps. Write this down, please, box 2. This is the second thing you need to be able to do. So I first ask you, hey, where's the variable? Is it by itself? So you're identifying whether the variable is on the left side or the right side, and is it by itself? Hey, if it's by itself, you're done. There's nothing left to do. You've solved the equation. But generally, it's not by itself. So if it's not by itself, the second question is, well, what's attached to it? If it's a 3-step equation, it'll be 3 numbers that you need to get rid of. Today, it's a 1-step, so there'll be 1 number you need to get rid of. So I'll say what's attached. By what I mean, what number is attached? Remember, we're only looking at the side that the variable is on. Either it's going to be the left side or the right side. Then I'll say, well, how is that thing attached to x? It's either going to be attached by addition, subtraction, multiplication, or division. So to get rid of it, you do the inverse. 3 questions, 1 statement. So it'll go something like this. Hey, where's the variable, left or right? You'll say left side. I'll say, well, what's attached to it? You'll say, hey, there's a 2 there. I'll say, well, how is the 2 attached to the x? You'll say, by subtraction. I'll say, well, what's the inverse of subtract 2? And you'll say, add 2. So I'll say, okay, add 2 to both sides. Do it. And then we go back to the first question. Now, is the variable by itself? Today, the answer will be yes. When we do a 3-step, you got to do that whole process 3 times. So the reason why I complain about boys is that no boy wants to do a 1-step equation. Yes, I'm being sexist here. Right? There are a few girls the same thing. But it always seems like it's boys. It's like, well, this is stupid. I know what added to 2 is 10, 8. So the answer is 8. Remember what I'm trying to teach you. To do a 3-step equation that you can't look at the equation and tell me the answer. You have to do it 1 step at a time. There's no process of doing a 3-step equation. There's only a process of solving a 1-step equation. You just do the 1 step 3 times. Okay. So, boys, pay attention. That's what we're going. What's the answer?
Okay.
What's the answer? See what I mean? Boys, right? You can't look at that and do that in your head. It's too complicated. But today, you literally can look at every one and do it in your head. Don't. Do the algebra, because that's next week. Maybe Friday? No, it's next week. Actually, it could be the 3rd, because it's 3 weeks to get through this. Well, this is where we're going. You're going to solve this by the end of the chapter.
Never
Okay?
mind.
This is pretty simple. It's not even complicated. It just takes a lot of steps. This is 1, 2, 3, 4, 5. This is 6 steps to solve this. And it's just 6 1-step equations. So let's look at 1-step equations. Once again, in kindergarten, they put a box here.
3.
It said, what plus 2 is
3.
5? And you put 3. The only difference now is we're going to solve that algebraically. It seems ridiculous to do it to a 1-step equation. It is ridiculous. But this is how you teach to do that 6-step one, is you do 6 1-steps. Because you can't look at a 6-step and tell me the answer. Okay, who wants to be the guinea pig?
Me, please.
Lucia, thank you.
No.
Right, so here we go. I'm going to do this every single time. When I say solve the equation, I'll say, is the variable by itself? Where is it?
It's on the left.
So if it's on the left side and you tell me it's by itself, the only thing on the left side is x. True or false?
False.
That's false. There's something attached to it. What's attached to x on the left side? How is 2 attached to x?
It's being added.
It's being added, so how do we get rid of addition?
Subtract 2.
So we are going to, now here comes, if there is a problem, here comes the problem. Everybody can do what we just did right there, but then they forget, well, what am I going to subtract from both sides? I don't care about the 5. It's not on the side of the variable. I'm trying to get rid of 2, so you do the inverse of add 2, you.
Subtract 2.
And then we're going to remember, whatever you do to one side.
Do the other side.
Now, occasionally I'll get students into pre-algebra that don't know how to write this. The book does a horrible job. No math teacher that I have ever come with ever has you write this from left to right. The book shows that. Every math teacher that I ever encounter all says, this is how you do it. Okay, there's the x, what's attached to it, plus 2, you get rid of plus 2 by subtracting 2. So underneath the number you're trying to get rid of, we write minus 2. But then whatever you do to one side, you must do to the other side. For addition, are you paying attention? For addition and subtraction, notice I didn't say multiplication or division. You write the minus 2 or the plus 2 underneath the things that you're going to be subtracting or adding, and then you draw a horizontal bar like you're adding or subtracting. New kids, have you seen this before? Right? I don't know of a math teacher that does it the way our book shows you. Our book shows you to write x plus 2 minus 2 equals 5 minus 2. Okay, yeah, you could do it that way. It just, you got to rewrite the whole darn equation. I can write this and continue. Lucia, 2 minus 2. 5 minus 2. So I get that. Yes?
Yes.
What's x plus 0?
0.
What?
X.
So therefore x equals 3.
Yes, sir.
This step right here is challenging to get people to write. So I usually say it's optional. Listen to what I'm saying. What am I pointing to? I'm pointing to x plus 0. I'm not pointing to minus 2 minus 2. That is not optional. That is required. But I agree that 2 minus 2 is 0 seems ridiculous to write. So you may skip this step. I will skip it eventually. First couple days I won't. But you cannot skip this step. Hey, x equals 3. Questions? Yeah.
So if there's a fraction, do you turn it into?
We'll talk about fractions later. And no, we won't do that. Okay. All right. We just claimed what was the answer? I'm going to show you what's called a check step. Not a requirement, but if you're wondering if you got the right answer, you take what you got, 3, and you plug it back into the equation and see if it makes it true. Is 3 plus 2 5? That's how you know it's correct.
Yes, sir.
Okay, that's called a check step. Seems ridiculous for a one-step equation. It's not ridiculous for 3- and 4-step equations. It's how you can check your work. Okay, we'll talk about check steps later on. All right, who else am I going to pick on? Hannah, thank you for volunteering. All right, Hannah, where's the variable, left or right side? Look at just the left side as the variable by itself. What's attached to it?
Plus 6.
How do we get rid of plus 6? You said it right.
Subtract it by 6.
Subtract 6 from both sides. So underneath the 6, we're going to write minus 6. Underneath the 4, because we've got to do the same thing to both sides, right? Okay, last year, the kids that I had, we didn't see a problem with this. Guess why? The answer is negative. You didn't know about negative numbers until the end of the year. So welcome to pre-algebra. We can deal with negative numbers now. What's 4 minus 6?
2.
-2.
-6.
See what I mean?
Yeah.
Right? You can mess this up pretty easy. Did I say you need to write this step right here?
I thought it was like
You can immediately jump to x equals -2. Okay? Be ready for negatives. They're going to happen every single problem, probably. You're going to have a negative number of some sort.
It's pretty close.
Yeah, there's 4.
All right. What's my message to the boys?
Listen.
I don't care that you know the answer is.
3.
I need to see the work. Okay? Where's, oh, new person.
Come on, you know.
Angelina. Hey, where's the variable, left or right side? Is it variable by itself? What's attached to it? How is 7 attached to x? So how do we get rid of add 7? One side or both sides? So we do -7. Do the steps, boys. Right? -7, because remember, this is where we're going.
Oh, okay.
Okay, so we're going to subtract 7 from both sides. What do we get?
On the right side.
You're done.
This is easy.
This is easy. Do the steps. Do the steps. Very good. All right. Oh, by the way, I know some of you, Landon, wrote this down. Did anybody come up with the answer yet? You don't have to. By the way, I haven't taught you how to do this one, but I know a couple of you want a challenge.
No homework for the rest of the quarter. Dude, the quarter ends in a week. Yeah.
That'd be a good bet to make.
Well,
Hold on, go back.
You guys don't know how to solve this, by the way.
I might.
That'd be 5.
Okay. For everybody else, this box 3. Here we go. Where's the variable left or right side, class? I'm looking at just the right side. Rectin is variable by itself. What's attached to it? How's 3 attached to x? How do we get rid of addition? What are we going to subtract from both sides? The number you're trying to get rid of, 3. So we subtract 3 from both sides. Okay? 21 minus 3 is, so therefore the answer is x equals 18, optional step, x equals 18. Hey, notice I said x equals 18. What does this say? Is that the same or different? It is customary when you write your answer to write variable equals answer. Not requirement, which is why I'm going to be lazy and I will rarely do that. Okay? For me, if the variable is on the right side, I'll leave it on the right side and be done with it. Okay. So just remember, though, the book will write x equals 18. You have 4 problems in front of you. Do them, please. Box number 4.
I think I got this. I'm not with the answer yet, but.
Nope, not even close.
Wait, I got a question.
Gabby.
Rip the dream.
It's easy. Hold up, my God, I did this.
Gabby's working ahead.
He's working ahead. Oh no.
She already figured it out. She didn't need to ask me a
I'm
question.
gonna give up. I got it to
Extra homework.
Anybody need help? Two negatives, what do you do? Add or subtract?
Small.
Same signs you subtract.
What?
Same signs you subtract. Same signs you add. Yeah.
This homework is the most
Have
easiest
you done
thing
this
in the
before?
world.
Yeah, but I just want to make sure you're doing the same thing both sides. So how do you get rid of +4?
Oh yeah.
Okay, yeah, what? Same different signs. What do you see different? So if you have same signs, you add or subtract. This is why it needs to be on your paper in front of your face, because you don't have those memorized. You got to add and then the same. And then you're adding negatives, so the answer's negative.
Oh God, I got to 4 steps.
We good? You got a question, or you just want to show me something? Is it the Gabby question? Who's sitting right next to you? Ask it.
Bro, how bad look at number 14, bro.
All right. Here we go. We'll start with Priscilla. First one, final answer. X equals. Priscilla didn't do that. She's doing her homework.
-2.
Priscilla and Gabby and Callie and everyone else that says, I already know what I'm doing. You got to still do this work so I can check to make sure you're doing this right. Jaden, you got an answer? What?
what are we on 4?
Upper left.
Upper left. I got -5 equals x.
Sounds good to me. Let's just go across. You get the next one. Bottom left. No, we're going to go from Jaden to the right.
8.
Tell me what to do both sides. Where's the variable? Left or right side? So I'm looking at just the left side. What's attached to the variable? How? Addition. So how do we get rid of it? What are we going to subtract from both sides? 4?
No.
What number are you trying to get rid of? So what are we going to subtract from both sides? So let's subtract 14 from both sides. That gives me, think it is through again. 18 minus 14 is? You can say it opposite. What added to 14 is 18. X equals, if I say it louder, maybe she'll say it. I can't hear what you said 8 the first time, and then I didn't hear if you said anything else. So x equals 18 minus 14 is 4. Okay. Next, upper right, sorry. X equals 9. And then the last one.
X equals -4.
This is the one that'll kick your butt. Why? Because we're subtracting 4 from both sides. Same signs mean you add, not subtract. So -14. All right. Hey, serious. We're moving on. But if this is something that I don't mean that you're struggling with subtracting 18 minus 14 or -10 minus 4. But if you're lost on why is he subtracting 4 from both sides? Why am I subtracting 1 or 7 or 14? That's what I need you to be brave during student advisement and ask me for help. Okay, Landon, Smalls. Where's the variable, left or right side? Okay, what's attached? Okay, how do we get rid of it?
By subtracting.
So to get rid of subtracting, we subtract.
Yeah.
Because the inverse of subtraction is subtraction.
Or no, add.
So what are we going to add to both sides?
We're gonna add 3 to
We're going to add 3 to both sides. Be careful. It's easy to make that mistake. Final answer,
it's 24.
x equals 24. Optional step. Okay? It's not optional to write +3 + 3. I got to see that. That tells me you know the inverse operations. You don't have to write x + 0 because 24. Check step. We're claiming the answer is 24. If I throw 24 back into x, 24 minus 3 is in fact 21. Okay? Abby, where's the variable? Left or right side?
Left side.
What's attached to it? How do we get rid of -10? One side or both sides? Okay? So we add 10 to both sides. Final answer? Apparently I like 14 today because I keep writing 14. Questions? All right. This is a hard one. Grayson, you want it? Where's the variable, left or right side? What's attached to it? How is the 8 attached to x? How do we get rid of subtract 8? What are we going to add to both sides? Don't screw this up.
4.
Give me the whole answer.
Oh,
X equals 4, 4 equals x. Very good. I thought you were going to mess that up. Good job. Okay. You will be so used to dealing with positives and negatives that this is the magic of 8th grade, is that, I mean, you remember last year and even the start of this year, same or different signs, add or subtract, all of a sudden that stops. I will have like 1, maybe 2 people. By Christmas, I'm still saying, hey, same or different signs, add or subtract, that sort of thing. Everyone else, you just kind of pick it up in 8th grade. And that way, when we get to this in Algebra 1 next year, we can speed through it real quick. All right, here's your first really weird one. I apologize for all that written over the top of it. Everyone stop what you're doing and look. If there's a mistake to be made, it'll be on this one. Check it out. Everybody can see that the variable's on the right side, correct?
Yes.
But what number am I trying to get rid of?
-3.
So people will see this plus, and they'll say, oh, I should subtract -3 from both sides. But I'm trying to get rid of -3,
So you add
so we need to add 3 to both sides. If there's a mistake to be made, I know why, because of that plus right there. Because remember, I could also write this as x -3, and then it makes more sense. They just wrote it in the opposite order. They put the x on this side, so -3 plus x, because x is positive. Okay? So it looks like it's attached by addition, right? Well, you're really adding a negative is what's truly going on here. So to get rid of adding a negative, you got to add a positive, okay? Who did I lose on that one? This is generally where I'll see a mistake made. What?
Are you allowed to put x plus -3?
You could.
Or you just want that's the
You
way I
could.
see it, with the
But I will say, for those that say they want to subtract, I mean, technically subtract a -3 is add 3. Subtract -3, 2 negatives, that makes a positive. So even if you think of this as being added to x and you subtract, make sure you just subtract the -3. That's the same as adding 3. All right, I don't want to confuse too many people. All right, do box 6, please. We're almost done, by the way. On the first page.
I was doing it wrong the first time, and then I figured out what you were doing, and now.
What is this symbol for?
Well, okay. What I was doing is I'll cross it out.
What's up?
So is the one?
It is, so add one to both sides. So if you're doing adding, subtracting, you're trying to figure out whether it's positive or negative. You look to the left of the number, and that's where its sign will always be.
Why does fractions have to be
Which one are you doing?
Oh, 27.
It's just a fraction. Good Lord.
Yes.
Huh?
I want to do that. That can be left out.
So change it to an improper fraction, get common denominator. You just took a test on it yesterday.
I did.
But you make all the other things a fraction.
Well, I'm just going to say, we're going to have fractions on almost everything that we do in this chapter. So if you're uncomfortable with fractions, then that's got to end.
No,
I said I feel this. I'm comfortable.
All right, Amanda, upper left, what's the final answer? X equals 11, good job. That takes care of that row almost. Genevieve, bottom left, what you got? Genevieve, bottom left, what you got?
Subtract X, and subtract the 4.
Because 4 is what we're trying to get rid of?
No.
Where's the variable, left or right side?
Like subtract the 4 from the X after you do that to the
Hold on, where is the variable, left or right side?
right side.
So I'm only looking at the right side. What do I need to get rid of?
6.
Okay, it's a negative 6. How do you get rid of negative 6?
Add,
So what's the final answer?
negative.
You just told me to add 6 to both sides, is what you told me.
10.
X equals 10. Now stay awake, please. All right, Avery, upper right.
X equals 9.
You got to tell me how you got that.
Oh, upper right, sorry. X equals 3.
Ah, X equals 3. Thank you. You're scaring me there for a second. I went even look at that one. I was like, how in the world did she get a 9? All right, last one. X equals 9. Questions? All right. Hey, what's the difference between box 7 and the rest of them? I changed it. Some things are being added, some things are being subtracted. So it's a combination of everything. So do box number 7 and then we're almost done. One more box after that? Yeah. One more box after that. This will be the Gabby question. I'll let Gabby teach you.
Yeah.
What? Same or different signs? So subtract. 10 minus 7 is 3. More negatives, more positives. Okay.
Finally. I don't like that. Why is it?
5. More negatives, more positives. You said 7 minus 10. More negatives, more positives.
Positive.
You said 7 minus 10.
Oh,
7.
yeah, 3.
Agree, but more negatives, more positives.
More positive.
Why do you say more positives?
Because 10 is higher than 7.
But 10 is negative.
It's not.
You said 7 minus 10.
It's positive.
Right. So you said it incorrectly. It's 10 minus 7.
I love this.
Does that make sense?
Because
You're not trying to get rid of 10, you're trying to get rid of 7. So you're subtracting that 10 from both sides, you're subtracting 7 from both sides. It's not 7 minus 10, it's 10 minus 7.
So if they're different, you subtract.
Always. And then you gotta ask yourself, same or different signs.
So for that long one, is these the exact same?
You just do those steps multiple times.
Oh, so I was doing it right, but I got the
Yeah,
wrong.
but you didn't get rid of multiplication.
There's multiplication.
How is the negative 2 attached to that parentheses?
Oh.
Multiplication, so you divide by negative 2.
Oh yeah, because 5x.
All right, here we go. I forget which row we have not done. Jenna's row. Jenna, upper left. What's the answer?
He's going by row. Okay.
Where the
What's the final answer, Joe? X equals 3. Very good. All right. What do you got, Priscilla? Well, what number are you trying to get rid of? That's not a 16. Look at it again. How do you get rid of negative 16? Add 16 to both sides. 16 and 72 is 80, 88. So X equals 88. All right, Gabby, upper one. So let's see, I'm trying to get rid of negative 17. So I add 17 to that side. There's more negatives than positives. So positive, I'm sorry, so negative 6. Did I say that right?
Yeah.
Okay, so X equals negative 6. Last one. X equals 15. Very good. All right, Gabby's going to teach us the last one. All right, talk, Gabby, talk loud so that e-learners can hear.
Okay, so since there's 3 numbers, you would switch
On the,
2 on the left and 1 on the right.
okay,
You switch the variable with the one right next to it, so it would be 9 plus 6, and then you subtract whatever you get from that.
okay, so hold on a second. What she's trying to say is this. She's saying if you have on the left side or the right side something you can simplify, right? Notice what I'm saying here. It says 9 plus y plus 6. Well, I can add 9 and 6, right? What's 9 and 6? 15. So you can group. I'm not subtracting anything from both sides. I'm not adding yet. I'm grouping things together. Sometimes you can do this, sometimes you can't. On this particular time, you can because they're all both on the left side. If 9's on the left side and 6 is on the right side, you can't group them together. Make sure you're listening carefully to what I'm saying. Hi. Step number 1 will now be always see if you can simplify each side. Is there anything to simplify on the right side? Is there anything to simplify on the left side? 9 and 6. Right? I can literally add 9 plus 6, which gives me
15.
You did not see this last year. Welcome to pre-algebra. At times, not always, but at times, you can simplify one or even both sides. Simplify the sides. Now what do we do? Subtract 15 from both sides and we get y equals negative 1.
Let's go.
More negatives than positives.
I knew it.
We better see that again. Look, anything to simplify on the left side? Are you paying attention?
Yes.
Anything to simplify on the right side?
Yes, 5 and 8.
What's 5 minus 8?
3.
No.
Negative 3. It's 2.
Oh, you're giving me a headache. All right. Be careful. Hey, different signs. That means you subtract. 8 minus 5 is 3. More negatives and positives, more negatives. So there. Oh, by the way, well, now what's the last step?
You do
Add
negative 25 plus negative 3.
No, absolutely
Add
wrong.
3 to both sides.
Add 3 to both sides.
Plus 3.
So therefore we get
Negative 22 equals j minus 3.
Okay, can I explain why it's plus 3 instead of
go
plus
for it.
negative 3? So remember how it's if you're adding, so it's hard to explain.
Well, then you just said, can I
I
explain?
can. The invert of addition is subtraction, so that would be plus, so j plus negative 3, invert of addition subtraction, so it's minus negative 3. And 2,
Does this make sense in your head?
No.
2 positives make it 3.
As long as Jaden understands it and he's doing the right thing, I'll let him go. For the rest of us, how do you get rid of minus 3? That would be my explanation.
It's easier to show on the wall.
Okay. All right. We don't have time to do these.
How do you do fractions?
How do you do fractions? You just took a test on
You
fractions.
just put every number over 1.
No, you just do whatever it says. All right. Look up here. I believe this is one of the ones. So it's like, I don't know, x minus 1/3 equals 4. Okay, what's attached to x?
3 1/3.
How's the 1/3 attached to x?
Minus.
So how do you get rid of minus 1/3?
Oh,
Stop, sit,
4 and 1/3.
sit. So we need to add 1/3 to both sides.
Yes, sir.
It'd be 4 and 1/3.
There is a mixed number one as well.
Yeah, that was it. Thank you.
Oh, bro, now I can feel my foot.
All right, e-learners, any questions? I will see you guys tomorrow since there's no questions.